The purpose of this video is to show how to fix one error that might show up when you're doing BSTEM simulations. The error occurs in the toe model output tab, where you're calculating erosion at the toe and the bed material. Now what I've put in here is the stream geometry, stream bank geometry that we used in the class problem. One difference here is that before I had 6.41, station 6.41, I had 0 elevation there. If you look at the profile that's shown over here on the right, the model profile, you have A to B and then B to BC and then through P, Q. Q is the beginning of the top of the bank toe, which here in our example is 3.95.57, and when we run the bank geometry macro, it's actually going to fill this whole thing in, and point Q will have the value 3.95.57 for the coordinates. What I've added in here is to make it so that we get all the way out to the midpoint of the channel, which would be W, point W, which right now is listed here as point E. When I run the bank geometry macro, that 10, 0 will get pushed down to here. All right, so let's see what we get when we'll look at the geometry of the bank. We'll also run the bank macro. Go back and look at the geometry. You'll see here that Q is now 3.95.57, which is the top of which is this Q point right here at the top of the toe. And there's some points in between Q and B. B is the beginning of is the bottom of the toe, the right-hand side of the toe. We just basically have a straight line between Q and V in the data that's here. We didn't put any other points in between. We could have, of course. And then W is all the way out here on the right-hand side. All right, everything else is the same as in the class problem. The thickness layers and so on, thickness of layers, the length of reach, the slope of the reach, the input elevation, and the input duration, 24 hours. So what we'll do is go immediately, all the strength properties of the different soil layers are the same as what we did in the tutorial. So we'll run the bank stability model, and we'll see that it is stable to start with. I get 1.2 for the stability, and of course I can run the toe erosion model, and it shows a little bit of erosion. We update that, so forth. We can go back and run the bank stability model again. Okay. And what we'll find here is that we can go through here. We'll have a couple of failures as we go through this step by step. Right now we're only at hour 24, the end of the first 24-hour interval. Further on, there is an error that shows up in the toe model output that makes it so that simulation can't continue unless you take some corrective action. I'm going to show you how to do that. I'm going to stall, or I'm going to pause the video, and I'll come back. We'll come back to it and and I'll show you, I'll come back at the point where the error occurs. So I'm going to skip over a number of different calculations. Okay, coming back to this, I had two 24-hour periods. So at the end of 48 hours, there was a slope failure. And then at the end of 2 more days of erosion, so at the end of 96 hours, had a slope failure. And then it went 3 days, 3 24-hour periods to generate a third slope failure. And now we're looking at the result of that third slope failure is this profile. And for that, the slope is conditionally stable at 1.03. Well, we find if I look at the toe erosion model, the 1.03 is a stable slope, conditionally stable. If I look at the toe erosion model, I find that this eroded profile is false here. It's extending back into the bank, and if I run this, I get a profile that goes like this, you can see, and then there's this error. So we get maximum lateral retreat is divided by 0. So it's not clear why this is occurring. There's something in BSTEM that's super sensitive to some calculations. So my fix to this is to go back here, even though this is conditionally stable. I suggest that one go ahead and accept this as an unstable condition and create a new profile. And it'll give you a warning. This is 1.03 factor of safety. It's conditionally stable. Are you sure you want to update it with a new profile? And yes, I'm going to do that. So this is the new profile. It should be stable. And it is. So now when we run the toe erosion model, we don't have that error where the eroded profile extends back here along the lower elevation here, along the base of the bottom layer. And we can continue with that. Continue to calculate factor of safety and erode it. And you can see that it's working, seems to be working fine. So there seems to be something about it when the factor of safety is close to 1. It doesn't necessarily always occur. Let's see. Now I have factor of safety 1.01. We'll run the toe erosion model, and we do not get that erroneous eroded profile that goes back along the bottom, the base of the bottom layer, layer 5. So we can continue with this. Okay, it's still conditionally stable. Okay, so that's a failed profile. Also failed profile. That was without any toe erosion occurring at all. So this one should be a stable profile. Conditionally stable, yes, but it's still stable. And the erosion profile looks good in this case. Okay, so we can continue to do that, and that seems to have worked. at least it appears that this fix to the model will get us by that error that occurs. And the amount of error that is associated with going ahead and allowing the profile to fail when it's conditionally stable close to 1.0 is not going to be that significant. With that, we'll finish the video.